Hi everyone, thank you for coming to my talk. My name is Samiul and I am a software engineer at Bloomberg. I live in New York. I was actually born in New York, grew up in New York, live in New York now, spent my entire life there. And I work on Bloomberg's IB application. IB is our chat app. So a lot of people use IB for finance and trading and research. And IB is our chat application that allows everyone to communicate with each other. So we build a lot of high throughput applications that process a lot of data, process a lot of data flowing around. And I code primarily in Python and JavaScript. I build full stack apps. So we normally do the backend in Python, C++. We do the front end in JavaScript and TypeScript. The title of my talk is You Came to a Conference, Now Go Do a PR Review. Kind of thought about this because I've gone to conferences before and I wanted to make my talk be actionable. If you're here, then either you or your company, you're investing time and money and resources to be here. And one of the things you want to make sure you get is something actionable where when you go back to, if you work on your own by yourself or if you work at a company, you want to make sure you take something away that can give you a lot of impact, that you can show impact with. And I think one of the things that gets overlooked that I saw in my career is that a lot of people think you can make a big impact by writing code and building things, which is true. But a lot of the times, PR reviews get overlooked, even though it's a really big, high-impact vehicle of making a big contribution in your org. I think with code that you write yourself, you can kind of only write so much code. You can only build so many things. But once you start doing PR review effectively, you notice that you can scale your impact to multiple people. So just really quickly, the agenda for today, we're going to talk briefly about why PR reviews are important. We're going to talk about the 3 archetypes of bad PR reviewers. So what makes a PR reviewer bad, what type of comments make those reviews bad. The bulk of it will go into Python-specific technical knowledge. I found that when I was growing from junior to mid-level to senior engineer, and I did more PR reviews and I looked at more people's code, there were a couple of Python-specific things that if you're knowledgeable about, it helps you kind of look at what someone's doing, try to figure out what they're doing, but then give them actionable advice so that they can improve as a coder as well. And then at the end, we're kind of going to wrap it up and figure out how to take the technical knowledge that you know with Python, but how to wrap that in a way where you can communicate that and people can get the most out of it. So really quickly, why PR reviews? They boost code quality and team learning. Like I said before, you might have a lot of knowledge yourself. You might have a lot of technical Python knowledge, but doing PR reviews is one way of giving that knowledge to people. I think their mentorship looks different. You might be mentoring someone one-on-one. You might get on Zoom calls occasionally. But the thing that's good about PR reviews is that someone is writing something and then there's like specific lines in code that you can point at and you can say, hey, you did this way. Did you intend to do it this way? Maybe you can do it this way. If you guys are all coders here, you know that you can read a book and you can read something kind of high level, but it doesn't really stick until someone points out something super objective to you and points out a specific line, and that kind of makes you think about it. So just boosts code quality and team learning. Another thing is that it helps catches bugs early. By doing PR reviews, you make sure that there might be things that you're aware of that could go wrong when this code rolls out to production. It just helps you catch them, helps you point it out, and then you just prevent fewer bugs rolling out. Mentorship and collaboration, I kind of talked about that a little bit before. And the biggest thing is that it's critical for scaling projects. Like I was saying, if you're an effective developer, you can only write so much code yourself. But if you're working on a really big team, some repos that we have, there's kind of tens of people working on it at the same time. There's a lot of code going in all at once, and you want to make sure that's scalable. One big way of doing that is to do PR review effectively, to make sure that there's a process, people know how they're getting feedback, they know how to take action on the feedback that you give them, so that ultimately you can just build whatever it is you're building. Cool. And then you might be thinking, so what's unique about Python PR reviews? Why is doing PR review for Python different than doing PR review for, let's say, C++ or JavaScript or any other language? It kind of goes into the language about Python and why it makes it unique. Python is dynamic. It's dynamic typing, which means that you need much more context about the code that you're reviewing. If something is more statically typed, you might be able to see the data flow a little bit better. But since Python is dynamic, you need to be much more aware of the context that code is changing. Python is very idiomatic. as programmers, we know that there are a lot of correct ways of doing something, but with Python specifically, we want to make sure that not only are they doing it correctly, but they're doing it the Python specific way of whatever problem they're solving. And then at the end, Python has batteries included. It just means that Python has a really big standard library, and a lot of people aren't aware of the features that Python has, so they might be coming up with their unique solution to whatever problem they're trying to fix, but they might not be aware of all of the different methods and all of the different libraries that already exist that let them solve the problem where they don't need to come up with something. So to just really quickly go over a few examples, Python being idiomatic, on the left, you can see the less Pythonic index loop where you do for I in range and you go over it, you get the index, you get the thing that's in whatever collection you're accessing. And then on the right, you can see that it's for I name in enumerate. So by using enumerate, it's not that you have fewer lines of code, but it's more Pythonic. And why? And we don't do this just because we like to do it. We do it because since it's more Pythonic, it's more idiomatic to Python, it kind of creates a pattern of the code in your code base. For code bases that are not that long, it doesn't make that much of a difference. But if you have repos that are tens of files that have a lot of lines of code per file, you kind of want to make sure that there's a subjective structure that that code is following so that you're kind of not having to go all over the place, having to jumble a lot of context in your head. And then Python has batteries included. So there's the with statement for resource management. There's collections without default dict. There's pathlib instead of of.path. There's lists, there's dicts, there's sets, and there's a lot more. On the left, you can see someone trying to open up a file without using with. And on the right, you can see them trying to use with. And in this particular example, not only is it more idiomatic, but it ends up being a lot fewer lines of code. Well, not a lot fewer, but go from 4 to 2. But again, for bigger code, for bigger repositories, this ends up having a very dramatic effect. And you end up having to have less context when you're looking at code, writing code, and then doing PR reviews. So let's get into the archetypes of bad reviewers. When I have a junior engineer, when I see people PR reviewing other people's code, I kind of see 3 main bad archetypes that I wouldn't want to be. It's the looks good to me reviewer, the technical nitpicker, and the nit commenter, and we'll go into those 3 in depth right now. For the looks good to me reviewer, they tend to leave vague and unhelpful comments. So they might simply say LGTM and then approve it, and then you feel like you're good to go. This have a couple of problems. One is if you're a new developer and you get a comment like that, you might think that you haven't done anything wrong or like you've fixed the problem correctly and you're like good to go. Even if that is the case, even if you're a new developer and your code is great, there's nothing wrong, you're kind of left unsure you're kind of wondering whether or not they even looked at your code or if they looked at different parts of your code. And it kind of makes it a little bit more ambiguous. You might have more questions about, oh, I thought I did this wrong. I was expecting a comment. Was this even looked at properly? And I think that creates a problem. And then these comments just fail to say what was reviewed and what was looked at. So I think if you're a code reviewer and you are looking at someone's code where everything looks correct, there's nothing wrong, I think it's still helpful to say what you looked at just so they know, oh, hey, I looked at this. It looks like you're solving this problem this way. And if you do that, it helps to make sure that you're not overlooking something, but it also gives the person that you're reviewing more confidence to know that, okay, you didn't just blindly approve this PR. There are things you looked at, you acknowledge the decisions they made and the work that went into it, and you're saying, okay, yeah, there's nothing wrong with it, there's no big red flags, this is what I've seen you do, and then you can still approve it, you can do the same thing, but you just communicate that differently by acknowledging what you looked at and what they did. Cool. So the next one is the technical nitpicker. So these reviewers tend to be very technically savvy, but they miss the forest from the trees. It's not that they're wrong, but it's that their reviews can be misprioritized. You might, if you're very technical and you have a lot of knowledge about the language or the system that you're working on, you might be able to give a lot of comments about, oh, use this data structure here, use this variable I've already defined here, do something like that. I think the issue with that is when you do that, you nitpick very few, maybe there's a lot of minor things, but then if you're on the other side of that PR review, you often don't know how to approach that. You might feel like 20 different small things, and then there might be a 21st comment that's like more design, more structural related, but if you're focusing on those 20 kind of nitpick things, you might over prioritize them and not prioritize something that might actually end up breaking in production. So in this example, you want to make sure that you might have a lot of technical nitpicks that you want to point out that might be very valid, but you want to balance that by kind of showing it to them in context and saying, okay, here are all of the smaller minor things that are wrong that you may or may not want fixed, but before that, this is a priority and this is what we should focus on first. And there's kind of different ways of going about that. One way might be kind of what I said, is giving context on the things that you comment on. But another approach is just doing one pass in your initial pass, focusing on the big picture things that might be a real issue if it rolls out. And at the end, just being like, hey, after you go through this, I have a bunch of other things I'm going to say, and then do a second pass where you would go through your more nitpicked items. But again, you just want to make sure you prioritize it. And then at the end, there's the nit commenter. This isn't technical nitpicking. This is just someone pointing out small, inefficient things that you might have done. To the reviewer, from the reviewer standpoint, they might have valid points, but the issue with this is that it's usually bad delivery and just ruins the impact. You might think that you say nit on something, but the problem with that is they usually don't know why you're saying it or what the issue is. And with people that leave like these nit comments, it ends up being an issue of they don't really know the context of how to take it, and they don't really know why you're saying what you're saying. So if you find yourself leaving comments where you're just saying, oh, this is kind of minor, you should do it this way, but I don't really care, which is what a nit comment really means, it's helpful to explain why you're leaving it. You can say, nit, don't use this type of loop, or don't use this data structure, use this other one, but then just explain why you feel that way. Because I think we've all learned before, you know that you learn the best when you're told why you want to do something or why you want to do something differently, not just that you want to do something differently for whatever reason, right? So you just always want to give the why. Great. If we're all good with that, then we're going to move into the next section, which is talking about the technical knowledge that I found is the most helpful when you're doing PR reviews. I think Python is a broad language that has a lot of different features, and you can kind of spend days talking about this, but I thought about the PR reviews that I've done over the past few years, the PR reviews that people have done for me when I was new, and kind of tried to bubble up the high-level things that I think is beneficial to know about. One thing that's really helpful to know about when you're doing PR review is Python's model. It's pass by object reference. So if you're coming from a language like C++ or some other language where you know exactly how variables are passed through, you might expect Python to behave similarly, but Python is not passed by reference. It's not passed by value, but Python's variables reference different objects. So what does that mean? It means when you're reviewing code, you always want to ask whether or not, if there's a mutation happening, is it intentional? I think people often forget that depending on the type that you pass into a function, it can be mutated or not depending on it. So immutable types are int, strings, and tuples. If you pass those three in, they are immutable. If you pass in lists, dicts, or sets, then they end up being mutable, and then you end up changing the state. So if we do a really quick example, you can see this add function. It takes a list, and it simply just adds one to each item. What this ends up doing is that since it's getting a list passed in, and lists are mutable, you might pass in a list 1, 2, 3, but then when you pass it into the function, it'll actually change that list, or it'll mutate the state of your code. This is a really trivial example, but what's important as a PR reviewer to know is that if you see code like this, you have to be aware that depending on the data structure passed into a function, you might be mutating the state, you might be mutating something. You just have to ask yourself, is this intentional? Does the person want to do this? Is this an accident? Are they aware about this? That's just one example. And then that goes into default mutable arguments. So when you're making Python code, you can put in default arguments where you want it to fall back if nothing is passed in. But again, you kind of have to worry about the same thing. So there's the code on the left where you pass in an empty list, and then on the code on the right where you pass in none. And then if I go to the next slide, you can see that the code on the left, since it is taking in a list, every time you call it, it is keeping track of its state. So you're not really getting a fresh list every time like you would expect. But on the right, if you make it none, it makes sure that the state in the overall code isn't being kept. And then that's just going to give you unexpected consequences in your code. So then default mutable args, what are some potential bugs with it? They're shared state across function calls, which you may or may not want. There's non-obvious behavior in loops. A lot of issues that I've seen where there's code being run and you kind of don't know why the state is the way it is tends to be because of different mutable args being passed in. And the args that are passed in are stuff that can be mutated. And then it's just hard to track side effects. So when you're doing a code review, you just want to make sure that if you see default mutable args being passed in, you want to make sure you have the context either by asking someone or by talking to them about whether or not they intend it to be this way. So whenever you see a list, a set, or a dict being passed in, your kind of alarm should go off, not in a bad way, but just is the person intending to do the thing that they're doing right now? And you should just ask if you see it. And now we can move on to efficient and idiomatic Python. So Python is very elegant. It gives you a lot of idioms. But if you're a reviewer, oftentimes you're really busy. You're doing a lot of code yourself, especially if you're a senior, you're writing code, you're reviewing code, you're architecting things. You might be having conversations with product and UX, like you're really busy. So you might default into being like, okay, does this just work? But if you do that, that might be quick early on. But as your team grows, as you look at more code, you miss the opportunity of making sure that your repositories are Pythonic. And that's the thing, that's where these Pythonic idioms come in, and you want to make sure that you're aware of them so you can incorporate them in your code. One example is loops versus list comprehensions. So loops tend to be verbose, but list comprehensions tend to be much more idiomatic. And it's not just about being Pythonic, just for the sake of being Pythonic. But in this example, you can see that there's fewer lines. What you want to express, the intent of it is more clear. And then we're not going to get into optimizations, but oftentimes the code on the right is often more optimized as well because different Python compilers know to look at different code and they can optimize it properly depending on which idiomatic Python you're using. Another example is map and filter versus comprehensions. It's easier to read for most Python developers when you have a comprehension instead of doing a map or a filter. It avoids anonymous Lambda functions. Like on the left, you can see there's a Lambda function passed in. I think ever since we got comprehensions, you're able to kind of do the same thing that you would be able to do with a map or a filter, but in a slightly shorter way that just makes more sense when you do it. And it just increases the modernity of your code base. You don't have to go back, and if you onboard someone new, they might look at a tutorial that's more recent, but then they might not know what a Lambda function is or how to look at it. So that's just another reason you want to make sure that you're up to date with like whatever new Python is, not just for the sake of using more modern languages or using more modern language features, but to do it in a way that makes your code easier to maintain long term. And then we're going to talk a little bit about generators. So generators, I see that a lot of people that are new to Python, they tend to not use them because they kind of don't know why or what they're used for. Before we go into actual code, just really quickly about generators, they kind of provide what's called lazy evaluation, and they're much better for if you're doing large data sets, if you're pulling in a large data set from a file, you can use generators to make sure that your code isn't taking up a lot of memory, and they just tend to work better with different tools like iter tools. You'll see them used a lot for APIs for ingesting log files. So in this example here on the left, you can see that we're reading a text file traditionally, but on the right, we're using a generator. And by using a generator, we're just ensuring that we're not pulling in all the context of that large txt file, and then we're kind of taking it in a more memory efficient way. So then for generators, I think the thing that I often ask myself whenever I see code is, if I see a for loop, could this for loop be replaced by a generator is usually one of the questions that I ask. And then if I see a list or any other large collection, is there any way I can incorporate a generator into this to save memory? But I think in addition to saving memory, there's also could I express what I'm trying to do differently? And I think that's one of the other key things in Python that I tend to do when I review people's code. I might see something that might look correct, but I always ask myself, is the intention that this person is trying to do with this code, does it make the most sense? And is there a better Pythonic, idiomatic way of doing the same exact thing? And now we can go into the tools in the standard library that I talked about. In the beginning, I said that Python comes with batteries included, and many developers don't really use a lot of the libraries that come in with Python. And as a reviewer, you want to see, if you see someone doing something in a manual way, Manual meaning they just kind of implemented a solution to a problem, but you know that there's a standard library method or library or something else that they could be using. You want to encourage the use of that. But in order to do that, you kind of need to know about them. So a few that I have seen that often get overlooked is using pathlib over OSPath. I think in this particular case, they're both 2 lines of code. They're both pretty easy. They both make sense. But the reason that you would want to use pathlib over OSPath is that there's a slightly cleaner syntax. And this isn't illustrated on this screenshot, but if you use pathlib, there's a lot more methods that you can use on the files that you're opening. There's retext, there's exist, there's glob, and it's just better for cross-platform safety. So in this particular example, it might not seem like there's a big difference, but then again, if you look at this code in the context of a larger code base, ends up being able to help the readability of that big code base and just taking away context that you might have to keep in your head. Another thing is default dict. On the left, you can see that there is a dict made with the curly braces, and then what that means is as you're iterating through it, you kind of need to check to make sure that something is there before you do something. But if you use default dict, you don't have to do that. So a benefit of using default dict is that it removes boilerplate and it just encourages you to write shorter code. I think that's one of the biggest things that I tend to look for when I'm doing PR reviews is, can this code be shorter? Not just for the sake of writing fewer lines, but every line of code that you write ends up being a line that you need to debug when something goes wrong. And I think if you guys work in production environments, you know that's not the case of if something goes wrong, but like when something goes wrong. And you want to make sure that there's the least amount of context you need to go through, and the least amount of context usually means the least amount of code. And you kind of just want to make it easier for yourself to debug things in production when it happens. When you see if key not in dict, that's usually a cue for me to say, could this be done better with default dict? And then another thing is type annotations. Type annotations isn't super new, but I haven't really seen them used in Python code bases as much as I would like. Most people tend to think about Python as a dynamic programming language, and they think of type annotations as something more static. Python does support type annotations. It doesn't enforce them, which is the difference. So if you put in type annotations, it'll make it easier for you to write functions, work with code that you haven't written yourself. It'll be quicker, which means if you're writing functions, you want to make sure other people can kind of integrate into your code base quicker. And again, it doesn't ensure any runtime thing being done. So even if these annotations are there, you can still write bad code and then run it that goes against them, and it will crash. But it just gives you one extra layer of safety to do. And it's something that I think is super useful that I haven't seen a lot yet. But another benefit of doing it is just to make sure that if you're writing functions or if you're writing classes and code, people understand the API that you're trying to implement. And it just makes it, again, one less piece of context you need to have in your head. And then similarly to type annotation, if there's data classes, I've seen people make classes themselves where they're trying to fit data. And if you can do that, there's nothing wrong with it. But you have to make a lot of boilerplate when you do that. So you have to define your own init. There's a lot of additional fields that you need to define yourself. But if you use a data class, you can just say, here's the value, here's the type for it, and there's a lot less boilerplate you need to write. And it makes it really clear that this is kind of, you're able to schema the objects that you're passing around your code. And if you're working with a lot of data, or if you're working with functions that process a lot of different things, you kind of want to structure them and define them so that it's easier for people to know whether or not this data will fit into the function that you're passing in. And that was kind of a bit of the technical stuff that I like to keep in mind when I'm doing code reviews, just to make sure that I'm giving knowledge that makes sense for this person so that they understand and they come out of the PR review knowing more about Python. But I think equally important to having technical knowledge is being able to communicate that knowledge effectively. Part of it is not being one of the 3 archetypes that I mentioned initially, but even if you're not one of those 3 different archetypes, you want to make sure that you give the information in a communicative way where it sticks and lands. So I'm going to go over a few principles that I like to keep in mind when I'm doing PR reviews and how I like to give feedback. I think it's clarity, respect, specificity, and then explaining why. So for clarity, it's say what you mean and be concrete. I think if you're a senior engineer, you might have a lot of context in your head. You might have all this information, and a large part of how you might either value yourself or the company that you're at might value you of how much knowledge do you have and how good you are at giving that knowledge to other people around you. So you might be tempted to say, let me give all the context I can just so I pass along all this information. But if you're doing that, you're not really being concrete, and it's kind of, as someone taking in that review, it's hard to see the forest from the trees. So you want to make sure that you're concrete and that you're saying what you mean. Respectful. Something that I've learned to do is to always assume good intentions. You never want to assume that someone is writing code that you think is bad, they did intentionally, or they just didn't look something up. I always assume good intentions, and I try to critique the code, not the person. PR reviews can be contentious, especially if you're working on something that has a tight deadline and it's super important. You can kind of, different personalities can get involved, but I think it's always important to kind of take a step back, keep your ego out the door, but then look at the code and not really look at the person writing the code. And then the next one is specificity. So again, I mentioned this early on. It's super helpful to get feedback on specific lines that you wrote instead of just getting generic feedback on the whole thing. So when you're giving feedback, make sure you point to a specific line or even a couple of lines where you're like, here's what you did, here's what you could have done better, or this might break. But be specific, not just with like the specific line on the code, but specific solution that you're recommending they do. And you want to make sure that you describe the issue, and then so what you feel like they're trying to do and the problem that they're trying to solve, but then give an actual suggestion on how they can improve the thing that they're doing. And then this one is super important to me, just explaining why. It kind of goes back into what I said early on, where you might review some code and you might not think there's anything wrong with it, and you're like, it looks great to me, you approve it and you're done. But a lot of times it's really helpful to explain why, not just when you see code that you disagree with, where you're saying, you should change this, here's why you should change it. But even when you see code that you don't change or you don't want to be changed, you can just be like, here's what I think you did, here's why I think your decisions were good, and that kind of helps reinforce positive habits from the person writing the code. So both for good and bad code, you kind of want to explain why it is that you're doing what you're doing. So kind of almost done. I guess takeaway for Python PR reviews. Python is an expressive language. There's a difference between working code and Pythonic code. And if you're working in large Python repos, you want to make sure that you make your repositories as Pythonic as possible, not just solving the problem, but solving in a Pythonic way. And that's just because as you write more code, as your repositories grow, it just makes it easier for you to maintain it, debug it, and move forward with it if it's all kind of one uniform thing. And you want to make sure you balance correctness with timeliness. You don't want to just give a lot of advice that kind of feels scattered. You want your advice to kind of follow a pattern where this is the most important advice. And then if there's nitpicks that you found, you want to make sure you give it to them so that they learn about it, but you don't want it to miss the big picture, and you don't want it to kind of take away from the real value that you gave them by doing the PR review in the first place. And then the most important thing, if you're thinking about why do I want to put in this much effort to do PR reviews in this manner, it's because that's how you scale your impact. There's only so much code you can write as an individual contributor, like an engineer, a senior engineer. You can only write so much code, you can only build so many things yourself. But if you're doing PR reviews, that's much easier to do at scale, because I think the more you do, the more you'll find patterns of either mistakes people do or good things people do, and it just makes it easier to have conversations about code. But most importantly, it just scales your impact, and it makes your value much more apparent to the people that you're working with. And that's it. Thank you for listening to my talk.